Angela is sitting at her lifeguard station on the beach when she sees a swimmer signaling for help. The swimmer is 85 feet out to sea on a straight line between the swimmer and the shore, and Angela's station is 175 feet down the beach from the nearest point on the shore to the swimmer. See the diagram. So here's Angela, the lifeguard station. Here's the swimmer needing help. 175 feet down the beach, 85 feet out to sea. So down here, Angela can swim at a rate of 5 feet per second and can run faster. So she obviously, like most people, she runs faster than she swims. Angela wants to get to swim as fast as possible. So basically, the idea is if Angela, you might think, well, Angela, just jump off your lifeguard station and swim. Straight line is the shortest distance. Yeah, but that's not going to be the shortest time, right? That's the shortest distance, but she swims slower than she runs. So probably better for her to run a little while and then swim. So there's less swim distance. Now you think, well, can she just run all the way? Then that'll be the shortest swim distance. Well, that'd probably be too far because that's a lot of travel. There's probably some point in the middle where she should, run to some point and then swim the rest, and that'll be the shortest. That's what we're going to try to calculate. So Angela wants to get to swim as fast as possible. We will label the distance Angela runs down the beach as X. So come in here and we'll say, okay, this is X, right? How far she runs down the beach is X. And then if Angela runs down the beach X feet, the distance she will need to swim diagonally is this. We got this from this is a right triangle, right? Because this part right here is going to be 175 minus X from there to there. Because if the whole distance is 175, take away X, this has got to be 175 minus X. And then right triangle, 85 squared, 175 minus X squared is C squared, A squared, B squared, C squared. Then you solve for C and you get this. So that's how they got this square root, because you would just say 85 squared plus 175 minus X squared, right? This side squared plus that side squared is this side squared. C squared, and then you root it, and that's how they got this. So that's C, that's the distance you should swim diagonally, okay? And then now so that's the distance. Now we want to know the time. How do you find time? Well, they got that from the basic formulas. Distance equals rate times time. So if you want to solve for time, you divide by rate. Boom. So time is distance over rate. So the distance she's going to run is X, and the distance she's going to swim is this. This is the swim distance. And so you take the distance she's going to run, X, over the rate that she runs. She runs 7 feet per second. Then that's the time that she's going to run. It's how long it's going to take her to run down the beach, X feet. And then the time it will take her to swim is going to be the, again, distance over rate. So there's the distance for swimming. That's the swim distance as we found out here. Distance. And this is the swim rate, right? She swims at 5 feet per second. So again, distance over rate, that's time. So this is the swim time. This is the time for swimming. So, all right. So then if you add those together, you get the total time, the run time, the swim time. That's the run time. That's the swim time. So we did all that in another part. So now, what do we need to do on this problem? So in this problem, all right, so we got the formula. There's the formula for the total time it will take Angela to reach the swimmer. There's her run time, there's her swim time, added up together. How far should Angela, so what is X? Basically, you want to get to the swimmer as fast as possible. So you want to get minimum time, obviously. So I came down here, I wrote the time formula, just took it right here and wrote it down here. I rewrote it a little bit, to make it easier for a derivative. Well, X over 7, 1/7 X. I put this 5. Oh, I make a, oh yeah, no, it's all good. It is plus in the middle. Yeah, that's plus. So yeah. So anyway, it's all good. So let's take the derivative. You know how we find minimum time. I'm going to take I'll say time derivative. So what's that going to be? Let me give a little more room here. We need lots of room. So the time derivative is 1/7. That one power just comes down, subtract one, that's gone. Plus now, you take that half power, comes on down, 1/5 times 1/2, and you keep the inside the same at first. So I'll keep that. And I'm just going to leave it 85 squared. I'm gonna leave a lot of things as they are, show you a way to make this problem easier. Okay, and then subtract one from that, so that'll become negative a half power, right? But then times the derivative of the inside because of the chain rule. Oh, yeah. So I'm gonna start doing a couple tricks. This one, I'm gonna do one trick right now. I'm gonna turn this around. I like X in the front. Now, is that okay to do? It is. Let me prove it to you. If you have 10 minus 2 squared, or you have 2 minus 10, what did I write? 8 there. It's 8 squared. And it was a little crazy. 2 minus 10 squared. What is that? Well, this is 8 squared. This is minus 8 squared. It's 64 either way. It makes no difference. So the order of subtraction, if you're in parentheses squared, it just changes the sign, but then you square it, so it's the same. So 175 minus x, x minus 175, whatever, same thing. Okay? Make it easier. So what now? So back to this rule. So I'm doing the derivative of this piece. You got to take the half, bring it down, and then subtract one from the power, makes it minus half. Leave the inside the same at first, but then the chain rule says times, from the chain rule, the derivative of the inside. Now, the 175, that's not going to do, I'm sorry, the 85, that's just a number of zero. But the derivative of this piece, yeah, we need to do that. That's 2, the 2 comes down, x minus 175 to the 1 power times, and the chain rule on here, that's just 1, right? Otherwise, it'd be negative 1. I don't want to mess with that. You know, if we had it like this, it'd be negative 1. I don't want to mess with that. All right. And then we what? We don't do that. We write better than that. We set it equal to 0, right? We take the derivative and we set it equal to 0 because when at highs and lows, the slope, the derivative is the slope is flat. At mins and maxes, so we want to find the minimum time. All right. So we have this equation. It's a messy one, but we can do some nice things to make it easier. So here we go. Um, what I'm going to do is, what am I going to do? This is not easy. I'm going to bump the 1/7 to the other side. So this is all one big term. You see, it's all multiplied together. It's all one big term. So that's going to be, oh, in fact, you know, here's, I'm going to do some tricks right now. The half cancels the 2. I'm going to start putting them together. They're gone. So then I've got 1/5. In fact, I'm going to make numerators denominators right now. I'm going to say we have x minus 175 over, and down below we have 5 and parenthesis 85 squared. Um, yeah, and let's just keep going. Plus x minus 175 squared to the positive half, right? So I take that negative power, move it down to the bottom. Right? Negative power jump to the other side. The 1/5, right? The 1 doesn't do anything. The 5 went to the bottom. If you want, you can put a 1 up here. There's your 1/5, if that makes you feel better. There's the 1/5. And there's the x minus 175. That's on the top because, again, that's over 1, right? Anything alone's over 1. So there we go, equal to minus 1/7. I move that 1/7 to the other side. Okay, what are we going to do now? Let's do this. Let's cross multiply. So I'm going to take all of this and multiply. Probably I'll take the. You can put the. You know when you have a negative on a fraction, you can put it on the top and the bottom or the bottom. Well, I'll just put it on the top. Whatever. It's a negative 1 up there. So I'll multiply these two. So what do we get? We get 7 times x minus 175 equals. And then on the other side, These two are multiplying, right? Diagonal, diagonal, cross multiply. So we get -5, -1 times 5. And then this is really the square root. I'm going to write it that way now. The square root of 85 squared is x minus 1. Now notice I'm leaving that inside. I'm not multiplying it out because something nice can happen. Do you see this guy and this guy? I'm leaving them because something nice is about to happen where I can get rid of them. All right, you good so far? I said cross multiply like that. Okay, now to get rid of that square root, I'm going to second power this side, second power that side. Okay, what happens? Over here we get 49 times x minus 175 squared. I'm just going to leave it because I want to keep that piece. Over here, you square the -5, that'd be +25, and you cancel the root. We get 85 squared plus x minus 175 squared. Okay, that would help if I put this print to a different color so you can see what we got going on. Okay, so now I'm going to take that 25, boom, boom. Again, I want to leave this. I'm hoping something nice will happen, and it will. So what do we got now? Now we've got 25 times 85 squared plus 25 times x minus 175 squared. Over here we get 49 times x minus 175 squared. Look at that. Isn't that nice? See what's going to happen now? I'm going to go subtract 25 times x minus 175 squared. Subtract 25 times x minus 175 squared. They're like terms. Boom there. So 49 of those x minus 175 squared, take away 25 of that same thing, leaves, I don't know, what does it leave? It leaves 24, yeah, of those x minus 175. So that's a big old like terms there. Here, we just bring these guys down. I'm just going to leave it as it is. I'll let Desmos do the work in a minute. 25 times 85 squared. Okay. Let's divide both sides by the 24. Trying to solve for x. Boom, boom. X was right here, so I don't want to be alone. Getting close to it. So then x minus 175 squared equals, again, I'm just going to leave it be and let Desmos do the work in a minute. No need for calculations. Okay, now I'm gonna square root both sides. Okay, so square root, square root. Now remember, when you put a roof on the house, up and down the ladder. Got to remember that, really important, right? Whenever we put a root on both sides, it's plus or minus because that'll be important here. These will cancel. So we get x minus 175 equals, and I'm just gonna leave this, plus or minus the square root of 25 times 85 squared over 24. Last step, bump over add the 175 to both sides, basically. I'll just write it this way. Add 175 to both sides. Boom. So there it is. X is 175 plus or minus the square root of 25 times 85 squared over 24. Now we go to Desmos. Okay. Try out the two options. Okay. I already forgot. It's 175, right? 175 plus or minus 25 85 squared. 175 25 plus, wait, square root of the fraction 25 times 85 squared. Is that right? Over 24, I think. 25 85 squared over 24. 25 85 squared over 24. Yeah. So let's try the plus option first. See what we get. 261. Could that be the real answer? No way. Let me show you. Why could x not be 261 and some change? Because look up here. What is x again? X is this distance she runs down the beach. The whole beach is only 175 feet. If she runs 261, she goes past the swimmer. How can that be the best way to get to the swimmer? To go past and then kind of swim back? No way. That's remember, math is a tool. It doesn't know what's really happening. That's a bogus answer. Let's try the minus one. Can't be two. So we go back and go, okay, it must be the minus. So just make the minus. And then we get 88.2472. 88.2472. 88.2472. Is that the real answer? Yes, it is. So in other words, she should run down the beach 88 feet, which is little less than half, isn't it? Yeah, a little less than half, and then swim the rest of the way. That'll be the fastest way for her to get to that swimmer. There is the quickest way. So interesting little problem. So again, just so if we'd forgotten the plus or minus here, and we just thought it was plus, then we would have got this crazy answer and wondered why we weren't getting the problem right. Very important. When you put a roof on the house, up and down the ladder, don't forget it because in this case, the plus answer was bogus, wasn't true, and the minus answer was the right one. That's how far she should run down the beach. So a little tricky on the steps there. Very interesting problem that we could calculate the best place to dive into the water. And so there we go.